Hey guys, it's Landon Blake. This is Taught by a Surveyor, taughtbysurveyor.org. We're doing some videos on unit conversions, the kind of unit conversions that land surveyors do. So in this video, I'm going to teach you how to convert from radians to decimal degrees and back the other way. Okay, so before we talk about that, we need to talk about what is radians, or what are radians, and what are decimal degrees. Okay, so angles, they're ways to measure angles, right? Angles, we're measuring the rotation or the revolution between two directions, okay? So let's start with decimal degrees because they're a little bit easier. Okay, so if you take a full revolution or first full circle, okay, decimal degrees just divides that into 360 degrees, okay? That's a base 60 system, okay? Base 60 we call it. It comes from the Phoenicians. Okay, it's similar to how we tell time. Okay, base 60. Okay, so 360 degrees. We're going to see a little bit later in degrees, minutes, seconds. So degrees, minutes, seconds is another way to measure angles that's kind of related to decimal degrees. We'll talk about that in another video. Okay, so for now, just remember decimal degrees takes the circle and splits it up into 360 parts. 360 degrees. Those parts are called degrees. Okay, radians. Okay, so decimal degrees are used by almost everybody to measure angles, except for surveyors and mathematicians. Okay, so mathematicians use radians and surveyors use degrees, minutes, seconds. Okay, which we'll talk about in another video. But okay, so mathematicians are in love with pi. I don't know why. They just something about people that do math for a living, teach math for a living. They just love pi. So they said, hey, let's come up with a way to measure angles based on pi. And so that's what they did. I think it's kind of clunky because pi is what we call an irrational number. In other words, we can't express it exactly in a decimal system. It just goes on forever and ever. The number just goes on forever and ever. But that's what the mathematicians did. So that's what we're stuck with. And if you're a surveyor, you gotta know how to work in radians. You should be able to do that. Okay. So the mathematicians said we're gonna say there's 2 pi radians in 1 revolution. Okay. So that means if you go all the way around the circle, there's 2 pi radians. Okay. So which means half a circle is 1 pi radians. Okay. And then half a revolution. Okay. And then a full revolution. Okay, is 2 pi radians. And so what we want to know is how do we convert back and forth. Okay, so let's just take an example. So let's just say we have 1 pi radian. Okay, and we want to know what is that in degrees, decimal degrees. I'm going to just abbreviate it DD. We want to know what that is. Okay, so First of all, we know pi is about 3.14, right? So we're going to say we've got 3.14. Let me carry it out a couple more places. Let's get my calculator here. Let's see, and hopefully it has pi. This calculator on my phone does have pi. Okay, so 3.14159. We're going to carry it out we'll carry it out to 5 places. Okay, so we've got that many radians. We want to know how many decimal degrees we have. Okay, so here's how you do that. We know there's 2 pi radians in a circle, right? So what we do, okay, I'm just going to write this out. So if you're converting from radians to decimal degrees, so from rad to DD, okay, the first thing you do, step 1, is you divide your angle in radians. Divide the angle in radians by 2 pi. Okay, what that's going to tell you is, what that's going to give you, that is going to equals your percentage of 1 revolution. Okay. So when we do that math here, we should get pretty close to half, 1/2, right? Percentage of 1 revolution. Okay, so I'm going to take 1 pi on my calculator here, and I'm going to divide it by 2 pi. Okay, so that's 6.28318. Actually, it's going to round up to 9. Okay, so I'm going to divide that. So 3.14159 divided by 6.28319. Okay, so that gives me a number that's almost but not quite half. So it's 0.49999. It's got 5 nines and then a 2. Okay, so if we round that up, it's going to round up to 0.50, right? So half a revolution, just like we thought. Okay, now the next step, once you have your percentage of a revolution, so we've got half a revolution, is you multiply your part of a revolution, your percentage of a rev, part of the revolution, you multiply that times 360, okay, and that gives you your angle in decimal degrees. Okay, so if I take 0.5 times 360 degrees, okay, I get 180 degrees. Okay, decimal degrees. So I'm going to just carry it out to one place. Okay, so that's how you convert from decimal degrees, from radians to decimal degrees. Okay, now let's take one other example. We'll do one more. Okay. So this time I'm going to say we've got 0.42 radians. Okay, and we want to know what is that in decimal degrees. So you remember the first thing we do down here, okay, we divide our angle in radians by 2 pi. So we're going to use that same value for 2 pi. So we're going to divide that by 6.28318. We're going to go 319. We're going to round it there. Okay. So 0.42 divided by 6.28319. Okay, so what that gives us, what that tells us is we've got 0.0674 revolutions of a circle. So we just have a tiny little bit. Okay, now we want to know what is that in decimal degrees. So come down here, we multiply that number we just got by 360 degrees. Okay, and what that tells us is, so when we multiply that by 360, okay, that tells us that we have, so that was a really bad equal sign, sorry guys, we have 24.26 degrees. This is the value in decimal degrees right here, decimal degrees, okay. All right, now to go back the other direction, you just reverse this process, okay. So to go back the other direction, you're going to take your value. So let's just say we have a value, we've got 42.5 degrees. And we want to know what is that in radians. Okay, so it's really simple. The first thing you do, take your angle in decimal degrees divided by 360 degrees. Okay, that's going to give you the percentage of the circle, the percentage of a full revolution. Okay, so we're going to go 42.5 divided by 360. Okay, that equals 0.11805. Okay, so that's how much of the circle I have. Okay, now we multiply that by 2 pi. So this number times 2 pi is going to give us our angle in radians. So we're going to say multiply that by, I got to remember what 2 pi is. So I'm going to just punch it on my calculator. Pi times 2, okay, times 0.11805. Okay, tells me that I have 0.7417 radians. Okay. So again, if you have a number in decimal degrees, divide it by 360. That gives you how much the percentage of a full revolution you have, the part of a revolution, okay, which is this number here. Okay, then multiply that by 2 pi. That gives you your value in radians. All right, so now you guys know how to convert between decimal degrees and radians, and from radians back to decimal degrees. You know all about that funky angle value, angle measure that mathematicians use. My buddy Brian Leiser, who was in the U.S. Army, told me that artillery folks in the Army also use radians, he believes. So there's somebody else that uses radians. Okay, so we'll do a separate video and I'll teach you guys how to go from decimal degrees to degrees, minutes, seconds, and back the other way. Now, I will tell you one thing. When you're doing these angle conversions, you got to be careful. You got to make sure that you carry your calculations out to enough places right of the decimal, because if you don't do that, you're going to introduce rounding errors. Okay, so most calculators will carry out to 8 or 9 digits past the decimal. If you run that, if you do that, if you carry that many digits of precision for most surveying math, you're going to be okay. But if you start truncating things, if you're only carrying it to 2 or 3 or 4 places past the decimal when you're doing these angle conversions, you can introduce some unnecessary error in your calculations. So just make sure you carry enough places in your calculator when you're writing down your numbers. You know, go to 7 or 8 or 9 places past to the right of the decimal point. Okay? Thanks for watching Taught by a Surveyor, guys. I appreciate it.